Hello guys. Today we are going to do the last lesson of chapter 8. There's actually more in chapter 8, but we're finishing up with lesson 8.4. So if you want to put a date on there, put your name on there. All right, let's get started. All right, so on your tip chart, your chapter 8 tip chart, the last two terms are angle of elevation and angle of depression. So I'm going to define those for you. So first of all, here's what an angle of elevation is. An angle of elevation is formed by a horizontal, which just means that it goes like this, and formed by a horizontal and a new line of sight when you're looking up. When looking up. That's called an angle of elevation. So here's what I mean by that. When you are just sitting there kind of normal and just look ahead and zone out, your eye looks straight across the room like this at a horizontal. It'll be parallel to the ground. If you just sit there normal and look straight ahead, your eyesight would go like that, would go straight across in a horizontal line, and it would be parallel to the ground. Well, so let's say this is your eye. So I'm going to draw a little eyeball right here. So that's your eye. This would be your normal line of sight. Well, suppose you see something up in the air, right? Well, your eye is going to look up at that thing in the air. Could be a bird, plane, Superman. Anyway, up there in the air. That's called an angle of elevation. Angle of elevation. The most important part is it's formed by a horizontal, and then your new line of sight when you're looking up. An angle of depression is that same thing. It's formed by a horizontal. It's your normal line of sight is horizontal, and a new line of sight when you're looking down. When looking down. So same exact words. All the words are exactly the same except you're looking down now. So an angle of depression is not a sad angle. It's an angle formed when you're looking down. So here is your normal line of sight. Here's your eyeball. Normal line of sight is horizontal. And then you look straight down, or not straight down, but you look down because you see something on the ground this time, maybe not in the air. And that is angle of depression. Just means looking down. Okay, so angle of elevation starts at a horizontal and looks up. Angle of depression starts at a horizontal and looks down. Now notice there are, in these angles, there are no angles like this because neither one of these is horizontal. Angles of elevation and angles of depression always start from a horizontal line. So there's no angles that look like that. Okay. One thing that's important to know is that whenever you have an angle of elevation, you have a matching angle of depression. So let me show you what I mean by that. Suppose there's a boat. We have ourselves a fisherman or a fisherwoman. So here's our boat, okay? We also have ourselves an airplane. Okay, I am terrible at drawing airplanes, but I will try. My airplanes usually look like flying fish. Pretend, see, looks kind of like an airplane, flying fish. Anyway, there's an airplane. All right, so here's the fisherman's normal line of sight. Just just fishing, normal line of sight. Well, the fisherman sees the airplane, so he looks up. This is an angle of elevation. I'm going to call it E for elevation. Well, at the same time, there's a pilot driving this airplane, right? And the pilot, his normal line of sight, or her normal line of sight, would be straight out from the airplane, horizontal. But the pilot spots the fisherman down there. Well, the pilot's normal line of sight is horizontal and is looking down at the fisherman. So this is an angle of depression. Well, since both of these lines of sight are horizontal, this is horizontal and this is horizontal, it means they're parallel. They would be parallel to each other. And we learned in chapter 3 that these two angles are called alternate interior angles formed by parallel lines. Those angles are congruent. So angle D is congruent to angle E. They are the same angle. Those angle measures are equal. So if this is 40 degrees, this is 40 degrees. So what I was saying was every angle of elevation has a matching angle of depression. So in your homework or on in the book, you might see questions like, they might say, describe this angle. Well, this is an angle of elevation from the fisher person's normal line of sight up to the plane. And if I describe this angle, it's an angle of depression from the airplane or from the pilot down to the boat. So from plane to boat. This is from boat to plane. This is from plane to boat. So they may ask you questions about describing those. Those angles would be equal. Okay. So over on your notes, I'm not going to define it again because it's right there on your tip chart, but this is what an angle of elevation would look like. I'm going to call that E. This is what an angle of depression would look like. I'm going to call that D. Okay, the good news is, in terms of math, that's the only new math, is those two new terms. So the math we're going to do in these problems is not new. It's just trig. So the only thing new is reading the problem, and so because they're all going to be word problems like this, and getting a drawing using an angle of elevation or depression, and we're going to be closing those off to make right triangles, and then we're going to use trig. So it says draw a picture and then use trig to solve it. All right, so I'm going to draw the picture for you, and you guys draw with me. It says the angle of elevation from a point to the top of a cliff is 38 degrees. Point A is 80 feet from the base of the cliff. How high is the cliff? So notice it says the word cliff 3 times. That means this thing's about a cliff. So I'm going to draw a cliff. Now, if you are artistically challenged, if you are not so good at drawing, you can just draw a cliff like that. A cliff that just drops straight off. So here's a cliff. If you're kind of artsy, you can add some trees. Okay, it says, we need to figure out where this point A is. It says the angle of elevation from point A to the top of the cliff is 38. This is the top of the cliff right here. Point A is 80 feet from the base of the cliff. Okay, this is the top of the cliff. This is the base of the cliff, right here. So top of the cliff, base of the cliff. Point A is 80 feet away from the base. So going 80 feet away from the base of the cliff, this is where point A is. Point A, 80 feet away from the base. And then it says the angle of elevation from this point A to the top of the cliff, from point A to the top of the cliff, forms an angle of elevation. See, there's our horizontal. This is going up to the top of the cliff. So here's our angle of elevation, 38 degrees. And the question is, how high is this cliff? Right now, I don't have the question in my drawing. So as soon as you get the question put in the drawing and call it X, then it looks more like the problems we were doing in our trig section. So it says, how high is the cliff? This is the height of the cliff. That makes a right angle. This is the unknown value that I'm looking for. So now, if you take out all the cutesy drawing part, the cliff, the tree, this looks just like a problem that we did in the last lesson, in the trig lesson. And in that trig foldable booklet, Looks just like one of those. So see, once you get the picture drawn using that new term, angle of elevation, then it's just a trig problem. So let's figure out what kind of trig problem it is. I always circle the angle of reference. I label the sides. I do not label this blank one. I noticed on the trig foldable booklet that some of y'all turned in that some of you had labeled this blank side. That blank side has nothing to do with this problem. So don't label it. Across from the 38, this is opposite. So this is the opposite side. Next to the 38, this is the adjacent side. See, that blank one's the hypotenuse across from the right angle. So I'm not labeling that hypotenuse. This is the adjacent side. So if you look at our definitions, oops, I thought I had a completed one here. Here, I'll look at these. The one that has opposite and adjacent, if you look at our definitions, opposite and adjacent is a tangent problem. So this is what my equation is going to look like. Tangent of the angle equals opposite over adjacent. So tangent of the angle equals opposite over adjacent. Looks like that. And then we have to solve this thing. So if you put that over 1 and you cross multiply, 1 times x is 1x. 80 times tangent 38. That's what I'm going to actually type into the calculator. 80 times tangent 38. You have to have a calculator to solve that. So remember, type the normal number first. 80 times tangent, what'd I say? 38. 62.5. So x is approximately 62.5, and this is measured in feet, so this will be feet. That's how high that cliff is. So that's that distance right there. Okay, I'm gonna skip number 2. And so I'm just doing a few of these. Go to number 3. It says from a lifeguard stand. So this picture is gonna be about a lifeguard stand. The angle of depression to a swimmer is 34 degrees. The stand is 15 feet tall. How far from the stand is the swimmer? So I'm going to draw a lifeguard stand. Here's our lifeguard. Lifeguard wears a hat. Lifeguard stand would have an umbrella. He's on the beach. Water. There's a swimmer out there. Now, if you I just kind of like to draw, y'all. So if you are artistically challenged, you can go lifeguard stand, water, swimmers out here, lifeguards up here, like that. Okay, so here's our lifeguard in the lifeguard stand. There's a swimmer out here. Swimmer. Okay. So it says, from the lifeguard stand, the angle of depression to the swimmer. All right, think about the lifeguard. Where is the lifeguard's normal line of sight? See, the lifeguard is just sitting up there, relaxing. Normal line of sight would be straight out like this. But the lifeguard spots the swimmer. So the lifeguard looks down at the swimmer. Like that. And it says, the angle of depression is 34 degrees. See, that's the lifeguard's normal line of sight. The lifeguard looks down at the swimmer. That's why it's an angle of depression, 34 degrees. Okay, the stand is 15 feet tall. That's this height. This height is 15 feet tall. And how far from the stand is the swimmer? So we want this distance. We want to see how far out into the ocean the swimmer is. Okay, here's the problem with angle of depression questions. Angle of depression questions are a tiny bit harder than angle of elevation questions, and here's why. This is what they call our working triangle. This is where the height is. This is where the distance is that we're looking for. This is the triangle that we're working in, our working triangle. Well, angles of depression are never in your working triangle. The angle of depression is up there. And so we need it to be in this triangle. And so that's why I told you a few minutes ago when we were talking about your tip chart that whenever you have an angle of elevation, there's a matching angle of depression. These two angles match. They're called alternate interior angles. So in this problem, this top angle here matches that angle there. So I'm just going to grab that 34 degrees and I'm going to move it into my working triangle. I'm going to put it right here. Now, the most common mistake with angle of depression questions is they'll draw the lifeguard up there and they'll say the angle of depression is here. But that's not an angle of depression because there's no horizontal there. So remember, angles of elevation and angles of depression start at a horizontal line and either go up from there for elevation or down from there for depression. So this is our 34-degree angle. We just needed to move it. All right, so here's my triangle now. And now we're going to solve it. Hold on, let me erase that. That's in my way. So here's what I want you guys to do. Pause the video. Using this working triangle, find out what kind of trig problem it is and write the equation and solve it. And then press play again. All right, so now I'm going to solve it. And hopefully if you paused it and now you press play, you're going to see me work it out and see how you did. All right, in relation to that angle right there, this is the opposite side. This is the X is the adjacent side. This is adjacent. I do not put a label on the hypotenuse, which is across from the right angle, because the hypotenuse is blank and it has nothing to do with this problem. So if there's a blank line, I don't label it because that might confuse me and make me think it's sine if I see opposite and hypotenuse. So I don't label the hypotenuse because it's not in this problem. So again, you look at your definitions, which one has opposite and adjacent, or you could always write this little memory device at the top of this little acronym at the top of your paper, or you could write it like this so that it reminds you of what these trig ratios are. If we have opposite and adjacent, this is a tangent problem again. Tangent of 34 degrees equals opposite over adjacent. So it looks like this. And then you put that over 1 and you cross multiply. So 1 times 15 is 15. Tangent of 34 times x. We can't actually do that, so I'm just going to write x times tangent 34 equals 1 times 15 is 15. See, if that was a number, I would multiply that number times tangent 34. But it's an x, so you can't actually multiply that. So this is one of those cases where you're going to need to get x by itself you're going to need to divide by tangent 34. So x is approximately this value, 15 divided by tangent 34. So in a calculator, 15 divide tangent 34. 22.2. X is approximately 22.2. And this is measured in feet. So that's how far away the swimmer is from the stand. This is 22.2 feet. Okay, the last one I want to do is example 4. So if you want to, pause the video and draw this picture. And then press play. It says a 40-foot tree. 40-foot tree. So this tree is 40 feet tall. 40 feet. It casts a shadow that's 58 feet long. So on the ground is this shadow. And the shadow is 58 feet long. 58 feet. Find the angle of elevation of the sun. Okay, so we need to think about where to put the sun. If the shadow is over here on the right, the tree's blocking the sun to make this shadow. So the sun must be back here. Like that. And here's why there's an angle of elevation of the sun. From our perspective, the sun starts at the ground. So that's why when you watch the sunrise, it looks like the sun's coming up out of the ground, right? So from our perspective, the sun starts at the ground and then it rises up in the air like this all day long. So this is our angle of elevation right here. And so I'm going to draw it. It's kind of like that cliff problem. This is an angle of elevation of the sun right here. So remember, elevation starts at a horizontal and goes up. So this is our angle of elevation. Notice the angle is what is missing. Okay, that's going to matter. All right, so pause the video and see if you can write and solve this equation. And then press play. So here's our angle of reference. Even though I don't know that angle, that's my angle of reference. This side is across from the angle, so this is opposite. This side is next to the angle. This is adjacent. Across from the right angle, that's hypotenuse. I'm not labeling that because it's blank, so it has nothing to do with this problem. And then if you look at our definitions, opposite and adjacent, this is a tangent problem again. Or if you look at our memory device, opposite and adjacent, our little acronym, that's a tangent. Are you guys getting tired of tangent? Tangent x. Now remember, these problems could be sine problems, they could be cosine problems. These are usually tangent questions, usually, because there's rarely a case where you're looking for this line right here going through midair. So you might be looking for that sometime, like a zip line problem. You might want to know how long that is, or like a radio signal. A radio signal can go through air like that. So those kind of problems, you might be looking for that line. But usually we're looking for a height of something or a distance of something. That's why tangent is real common with these word problems. So anyway, tangent of x is opposite over adjacent, 40 over 58. Okay, when the angle is unknown, cross multiplying does nothing for you. If you put that over 1 and cross multiply, you've still got tangent of this unknown value. So whenever the x is the angle, you don't do the cross multiplying thing. So whenever the angle is x, you have to use the second function button in your calculator. See, we're trying to get x by itself, so we have to get rid of the word tangent, and to get rid of the word tangent, you use inverse tangent like that, and that's going to give you x. So we're punching into our calculator second tangent, and then you type in this fraction, 40 divided by 58, and you get about 34.6 degrees. They like angles to be nearest whole degree. So see, that 5 is going to round that 4 up. See, if this number is a 5 or higher, that rounds up, so it's 35 degrees. Approximately 35 degrees. They like angles to be whole numbers. So that's that angle measure, is about 35 degrees. Okay, whenever the angle is missing, that's when you press second, in this case tangent, sometimes it's second sine, sometimes it's second cosine, and it gives you that tangent -1. So that's what you do whenever the angle is missing. Okay, so the math here, what we actually did to solve these is no different than the trig lesson. The only thing new is getting these drawings that show you triangles from the word problems using angle of elevation and angle of depression. So that is the end of that lesson and the end of chapter 8. So y'all have a great day. Bye.